Hello everyone, this is Haijing Tian. This video we are learning chapter 3.3, the unit circle and the circular functions. What is unit circle? If I have a circle, I put it on the standard position. Here is the center. So unit circle means the radius of the circle is 1. So R equals 1. It's satisfied one condition is, for example, any point x comma y on the unit circle, x squared plus y squared equals r squared. Why? I can form a right triangle here, for example. All right, I know that from the center to the point, that is the r. And how about from the center to here? Is this the x? Yes, because my point is x comma y. So this distance is x. How about the height? This is the distance from this point. Then draw a vertical line. This is a y. Oh, this is right triangle. So x squared plus y squared equals hypotenuse squared. All right. Let's see the example one. Is this point on the unit circle? I need to use the formula x squared plus y squared. If it is equals 1, the r squared, because r equals 1, which is 1 squared, which is 1, then I can prove this point is on the unit circle. Let's see. Is this point on the unit circle? The x squared negative 1/2 squared plus the y squared square root of 3 over 2 squared. What is that? It's 1 over 4 plus I need to square the top and bottom because inside is a fraction. Square the top, I got 3. Square the bottom, I got 4. Then add them up, I got a 4 over 4. It is 1. That is r squared, 1 squared. Yes, this is a point on the unit circle. Let's see, next part. Let P be a point on the unit circle. T is the arc length. What is the formula of the arc length? For example, I have the arc length is T. T equals r theta. So before we have learned, we use symbol S equals r theta, but now in the question says T. And how about the r? What is the value of the r, the radius of the unit circle? 1, r equals 1. That means T equals theta. This theta has no unit, and this T has a unit, for example, inches, centimeter, meter, but the value, they are the same. That means if I have 6 trig functions, for example, I have sine theta, cosine theta, so the theta can be replaced by T. So if the theta equals T, so all the 6 functions, they can be replaced. The theta can be replaced with the T, sine T, cosine T, tangent T, and their reciprocals. And remember that T and theta, now they are all, theta is in the radian mode. It's not in the degree mode. All right, let's see. Next part. If I have a point on the unit circle, for example, do not look at this. First, do not look at this. I have P equals, is a point x comma y. So if I have my angle theta equals T, so what is sine T? Sine T equals y over r. What is the r? R is 1. That means I can get a y. And how about cosine T? Cosine T, that's x over r. R is still 1. So I have x. Okay. That means my x is cosine T, my y is sine T. How about the coordinates x comma y? Can I replace the x this x with a cosine t? Yes, we can. And can I replace my y with a sine t here? Yes. So if I have a point, I can replace the xy coordinate with cosine t, comma sine t. All right, if I have the cosine t equals x, sine t equals y, how about the tangent t? Tangent t equals y over x, just y over x. X is not equals 0 because if it's 0, the fraction is undefined. And the reciprocals, secant t is 1 over x. Cosecant t is 1 over y. Cotangent t is x over y. All right, let's move on to see the special points. If I have points 0, 1 or 0, -1, they all have the x equals 0. Then tangent and the secant t are undefined. What is tangent t? Tangent t equals y over x. If the x is undefined, x is 0, this is undefined. And what is the secant t? So secant t equals the reciprocal of cosine. So I'm having r over x. So the bottom has the x. So when we are having these 2 points here and the point here, the tangent and the secant, they are undefined. How about another 2 special points? Another 2 special points, they are 1, 0, -1, 0. They are the points here. They all have the y equals 0. So what is cotangent and cotangent and the cosecant? They are undefined because the cosecant is 1 over sine. 1 over sine is r over y, and the cotangent t is the reciprocal of tangent, that is x over y. The bottom, they all have the y, and here these 2 points y, they are zeros. So cotangent, cosecant, they are undefined at these 2 points. Okay, let's see the first example. Example 2. Suppose t corresponds to the point P on the unit circle. Evaluate the 6 trig functions. Okay, the unit circle, r radius equals 1. And the first coordinate that represents a cosine t. And the second coordinate represents sine t. Because we did the conclusion here, this part and this part. All right. If I have known that the cosine t is the x value, -2 over 3, okay, I can also know the sine t. Sine t equals negative square root of 5 over 3. How about the tangent t? Tangent t equals sine over cosine. And this is the identities. You can also use a simple one, which is the y over x. What is the y? Y is negative square root of 5 over 3 over x. X is negative 2 over 3. Negative, positive solution. And use the KCF. K is keep the square root of 5 over 3. And change the division to multiplication, flip the bottom fraction, 3/2. And then 3 canceled. I got square root of 5 over 2. I used too much space here. All right, let's find the reciprocals of these 3 functions. Sorry. Cosine t's reciprocal is secant t. Secant t equals, you just flip it, okay, keep the sign, -3/2. How about cosecant? Cosecant t is -3 over square root of 5. I need to rationalize this one. Square root of 5 times square root of 5. I'm having negative 3 square root of 5 over 5. Nothing can be simplified. Keep this value. And how about the cotangent? Cotangent t equals reciprocal of tangent is 2 over square root of 5. Continue to rationalize this. I'm having 2 square root of 5 over 5. All right, we found all the values. How about the next one? All right. So now, if I have a point on the unit circle, I have a point P, and then I have a theta. For example, if I don't know the coordinate of the P, I don't know what is the point value, but I only know that theta equals pi over 3. And that represents T also equals pi over 3. Can you find the coordinate of the point P? So we know for the P point, we have cosine T, comma sine T. If the T is given is pi over 3, I can find the value here. So let's find cosine pi over 3. That's cosine 60 degree. What is cosine 60 degree? That's 1/2. And what is sine pi over 3? That is square root of 3 over 2. Now I can find the point is 1/2 comma square root of 3 over 2. So if I have a point, I can find the coordinate of the point P. So how about the other values? So I found the first point P because this angle is 60 degree, also means pi over 3. How about the 45? This angle is pi over 4. Can you find the point here? Yes, the first value is cosine pi over 4, cosine 45 degree, which is square root 2 over 2. Second coordinate is the sine pi over 4, which is square root of 2 over 2. And the next point, next point P represents theta equals pi over 6, which is 30 degree. And the first coordinate represents cosine 30 degree or pi over 6. Second represents sine pi over 6. So they are square root of 3 over 2 and comma 1/2.